Okay, in today's video, I will give you something like detailed information about how to design and also uh, we try to find out whether our gearbox. So this is talking about gear and also the gearbox system. And uh, in designing gear and gearbox, we need to know actually how safe our gearbox system. So it's depend on the most critical part inside. So for example, the opinion, one of the opinion is critical, so we need to know how critical, how much critical. So this is will be talking about how to design the gear, detail gear. So I have created a formula section in the first sheet because a lot of formula in this gear analysis. Okay, and uh, from this formula we will something like try to solve simple problem first. And yeah, this is one of the tutorial in the Swinburne University. The class name is Machine Design Project, and I'm one of the tutor, and I give them tutorial uh, about machine elements, and one of them is gear and also gearbox. So this is a gear section, and yeah, this is very interesting because I have experience on this kind of problem. I got first winner in the creative design competition in Indonesia, and we used something like emergency portable charger product. At that time, we convert the high torque and low velocity from the hand power to the high velocity low torque for the motor. The motor will generate 5-volt electricity, and it's enough to charge your phone at emergency, of course. And mm, yeah, because of that competition, remind me about how we design from scratch to the product. We analyze each of the gear and how much the safety factor. So this long calculation is actually end up with safety factor in the last column. This one is the best things at that time. How our product is coming out as a winner because yeah, we applied the engineering analysis very detailed in the presentation in the report, and yeah, we got the winner at that time. Okay, in this time I will give something like a brief and big idea, the big idea how to calculate from scratch to the safety factor. Okay, for example, we only have two application, whether reducer or increaser, something like we reduce the speed at the output. So input has a DC motor high speed velocity, and the output is low velocity but high torque, and that is a reducer. And for the increaser, something like we want to get more velocity at the output and low torque at the output. It's just opposite. We can reverse actually for the some of the gearbox configuration. We can just reverse something like planetary or spur gear, multi-stage spur gear gearbox. We can just reverse it. But for rack and pinion, it's very difficult to reverse. Okay, and okay, this kind of example. For example, I have two stage gearbox. So this one is one stage and this one is second stage. So improve the gear ratio. Improve gear ratio means no, no, not improve actually. The gear ratio it means we can improve the torque 9 times or the speed 9 times, depending on your application. So, for example, I want to get a reducer gearbox, and I design. This is actually example in one of the tutorial question. So, at this moment, there is a known parameter and also unknown parameter. So, for example, if we want to coming out with a high torque, this one, the 71 maybe uh, what we need is 70. For example, we need 70 newton meter, and we come out with the 71. That is enough. So this is the important value here, and also this is the initial value, and this is the initial torque here. We want to convert to the 71, which is 9 times, and also the speed is reduced 9 times. Okay, and yeah, the first thing when you have uh, when you design something and you put the final torque here, so this is as the, for example, your limit is 70, means yeah, it's passed, it passed, all your design is perfect. So yeah, that is how the goal set in this kind of design of gearbox. and and then uh, we need to detailedly define what is this, what is that. Okay, just quick calculation, quick explanation. So this is number of teeth, this is diameter, and also radius in SI unit or imperial unit, depend on your calculation. If you want to use SI unit, just use this. If you want to use imperial unit, use inch. And also the pitch, diametral pitch for imperial unit and module for SI unit. This is the identity and compatibility value of your gearbox. Okay, and then this is normally standard. Just put some value and you will the software will generate your gear. This is the RPM, this is the torque, and from the torque sometimes the torque is lost, so you need to put 95% loss in the each shaft. And also this is the for tangential force. Tangential force is also critical. Why this is critical? Because uh, it has it creates the bending stress at the root of the tooth. So this is really critical to calculate stress. And radial force, which is Fr, is actually not really critical because only compression and also not really big value in the force. So stress also not really bigger deal, not a big deal. And then the big deal is the bending stress here. So we calculate this one is this. This is the, theoretical. Theoretical value means you you only come out with the ideal condition. So we have the other version which is more precise and realistic value, which is coming from AGMA, American Gear Manufacturer Association. They come out with this formula which is really detailed and also validated through the experiment way. Yeah, of course they have their own methodology to calculate more accurate stress. So let's start with this. This is the Lewis graph. Lewis graph identify easily the correlation between age this h and t without knowing that value, because this this theoretical value, we need to put the h and t, because h and t sometimes we don't know, because this is depend on your module, depend on your diametral pitch, because we don't know. We just somebody named Louis developed a graph called Lewis graph that correlate between number of teeth and also Lewis form factor. This is very useful when you only have the number of teeth and you want to know the y value, and also you at the end you can calculate the stress, the theoretical stress. Theoretical stress sometimes much lower, even almost the half of the ACMA version. And yeah, this is too ideal, maybe too conservative. And how to calculate the ACMA stress? Yeah, using this one. And J is geometry factor, KV is velocity factor, KO overload, and KM is mounting correction. All of this value actually available in the textbooks. This one for KV, this one for correction overload, this one for mounting, and put everything. This is not a big deal actually. This is just for it's like matching the graph, not really uh, require high order thinking. Just put everything following the graph, and at the end you will get, yeah, this kind of formula. This is actually the first the version of the ACMA coming out with the inch psi, I mean, for the pressure or stress. This psi just convert to MPa, and we will know, we can compare easily with this one. So it's clear that, yeah, this if we have the safety, if we have fatigue stress can be defined with this formula. Long formula is actually you calculate using load factor, depend on the load factor, gradient factor, surface factor, temperature factor, reliability factor, all put together. I assume all is one, and for the steel is just 250, and uh, this divided by this, you will get the safety factor. This one is most critical value. We want to know, is it safe or not, is it critical or not, which one of the gear is critical. So the good things, you can only improve in not only you the simple things to do to improve the safety factor. You can increase the b, for example, we increase become 7, and yeah, this one is increased if we redo, and yeah, this the b1 is critical, very straight to the improvement p value. And also we can increase the number of teeth, something like maybe 16 or 17, and then we will get improvement. Yeah, that is how we improve. We can, I think we can improve with the other parameter, but maybe m or p, you can also do that. And then for example 3 stage, 4 stage, 5 stage, you just add up the other line. And for example you just design the module one means very easy. You can directly got the diameter with only multiply m with the number of teeth, and you will got the diameter. Easy, very easy. So SI unit is more easy for me. And for the tip per inch, yeah, this one is 1 inch. This one millimeter per tip. This is just, oh no, 20 one 10 inch. This is actually 10 inch. 25.4. Oh no, no, just four. So the diametral pitch is slightly different. Depend on your preference. If you want to use module, just use this value. Easy. This is for small gear, but if you want to make a bigger gear, of course you need to make it bigger. Okay. Okay, with the same way, at the end we will coming out with the stress and other safety factor. Okay, this one. The critical one is the last two gears. This gears is the safety factor 2 is, yeah, that's enough because at least we have one. One is, the meaning of one is actually the Vedic stress equal to the stress of the uh, bending, bending stress. So it's not really good because if you have overload capacity from the limit, and your gearbox system will fail abruptly. That is not good. And that is how you calculate um, one by one each gear and design it very detailed. And the good thing is you know which one is the critical, and you can just focus on that critical part, whether you can improve the thickness, improve the diameter, or also you can, yeah, you can make it more strong, surface treatment, everything. So yeah, this is one of the tutorial. Maybe this is not available in the internet, but you can contact me if you want. But yeah, this is not really open for everyone because you can only see in this video. Okay, thank you so much. I think that is for today's tutorial. Thank you so much.